Question number 14 is going to use a substitution. Now, this substitution is a little bit different than the normal substitution. So we're going to take a look at this and take a look at that inside function, x minus 1, and we're going to let that be our u function. So let u equal x minus 1, and that makes du the same as dx, which is kind of convenient. Now, the reason why we make this substitution for x minus 1 is that this binomial inside the root is a bit of a problem. We can distribute if that x minus 1 was in the square, and that would kind of solve that little bit of dilemma we have. And that's what we're going to do. We're going to rearrange this equation and let u plus 1 equal x. And we're going to do our substitution this way. So we're going to have our x squared, and we're going to replace that x squared with a u plus 1, and the square root part, we're going to replace that with u. Now that doesn't look very different, and sorry, the du is going to be replaced by dx is replaced by du. Now this doesn't look that much different, but it allows us to deal with the power much more easily, because we can distribute the power onto the x plus 1, and then we can distribute that 1/2 power onto the remaining terms. So when we distribute the exponent here, we end up with u squared plus 2u plus 1. That's all going to be multiplied by u to the power 1/2. And then notice that we can put the power onto the u, and then we can just use power rule here. Okay, so once we establish that, we can integrate this. We end up with u to the power 7/2, divide by 7/2, plus 2 times u to the power 5/2, and then divide by 5/2, plus u to the power 3/2, divide by 3/2, plus c, and then we can do our final substitution. So this becomes x minus 1, 7/2, plus 4/5, x minus 1, 5/2, plus 2/3, x minus 1 to the power 3/2, plus c.